Chemistry. I've had some questions on lesson 3, balancing chemical equations. You have to know how to do this in order to move on to lesson 4 and lesson 5, because we use this a lot in those lessons. So in balancing equations, we're going to use the law of conservation of mass, which says the mass of the reactants must equal the mass of the products. So on one side of the equation has to equal the other side of the equation. It has to be balanced. And the way we're going to do that is by inserting coefficients. So I'm going to go kind of quickly through this and then do some of the homework problems for examples. Okay, so in the example on your notes, we have H2 plus O2 yields H2O. That's water. If we put hydrogen and oxygen together, we're going to get water. Remember that hydrogen and oxygen, when they are by themselves like this, have to have 2's there because they are diatomic elements on the periodic table. Remember that when we had those 7 diatomic elements that made a 7 on the periodic table that always have 2's? Hydrogen and oxygen are some of those. So that's why they have 2's right there. When they're by themselves, they always have to have a 2. So in this problem right here, we've got 2 hydrogens on this side, and we've got 2 oxygens on this side. But over here on this side of the problem, we have only 1 oxygen and 2 hydrogens. Okay, we got 2 oxygens here, 2 hydrogens here, but over here we have 1 oxygen and 2 hydrogens, and this isn't balanced. You can see by looking at it right here that it's not the same. There's not the same number of hydrogen atoms on this side as there are the same number of hydrogen atoms, but there aren't the same number of oxygen atoms. So somehow we have to balance this equation so that it is the same. And the way you balance equations are by inserting coefficients. This is just like in math. Coefficients go out in front. Remember in math when we have like 2x plus 3? This is the coefficient of x. It's the number out in front. So somehow we have to balance this. So let's, in order to, we only have 2 oxygens on this side, and we only have 1 oxygen on this side. So if we put a 2 out in front, a coefficient, now we have 2 hydrogen, or we have 2 water molecules over here. So we could write another one because we put the coefficient out in front. So now we have 2 water molecules. So now our oxygens match on both sides of the equations, but now our hydrogens don't match because now we have 1, 2, 3, 4 hydrogens, but we only have 2 over here. So we're going to put a 2 in front of the hydrogen. And on this side, we're going to have another hydrogen atom. And now everything matches. You see this? We have 1, 2, 3, 4 hydrogen atoms. 1, 2, 3, 4 hydrogen atoms. We have 1, 2 oxygen, 1, 2 oxygen. Everything is balanced, and our coefficients are the numbers that are out in front here. So here our coefficients would be 2, 1, 2, 2, 1, 2. If our coefficient is a 1, we don't write it there. We don't usually write the 1, just like we don't write 1x in math. And the reason we write the coefficients like this is so that we can look at them to see if we could reduce them. Nothing goes into 2, 1, and 2, so they are as simple as we can be. So that's what we're doing in this section. We're balancing the equations. If you look on your notes on the back side, it says when balancing an equation, you cannot change subscripts. We can't change these numbers down here. And because if we change subscripts, we change what it is. If we changed this, the subscripts down here, if we put a 2 by the oxygen so that they would match, then it then that makes a different compound. We can't do that. You can't change the subscripts. What you do is put a coefficient like this out in front. That is what is going to balance our equations, okay? And the balanced equation is a ratio and must be expressed in simplest whole numbers. So that's why we look at these coefficients, to make sure that they are the simplest whole numbers. The coefficient times the subscript tell you how many there are. So in this right here, 2 times 2 tells us there are 4 hydrogen atoms. 1, 2, 3, 4. Over here, 2 times 2 tell us there are 4. 1 times 2 tell us there are 2. 2 times 1, because there's a 1 there, tell us there are 2. So that's how you decide how you are going to balance the equation. So let's look at another example on your notes. We're still going to look at the notes. Okay, we've got NaOH yields Na2O plus H2O. So we got to balance this. On this side of the equation, we have 1 Na atom, and on this side, we have 2 Na atoms. On this side of the equation, we have 1 oxygen, and on this side, we have 1 oxygen here and 1 oxygen over here. So that equals, I'm going to put X's by those so you know they're oxygen. That gives us 2 oxygen. And on this side, we have 1 hydrogen, and on this side, we have 2 hydrogen. So we are not balanced. Our sodium is not balanced, our oxygens are not balanced, and our hydrogens are not balanced. So I'm going to start by trying, sometimes it's just trial and error. I'm going to start by looking at the sodium. I got 2 of them over here. I only have 1 here, so I'm going to put a 2 in front. If I put a 2 in front of here, now I have 2 sodium, and I have 2 sodium over here. But on this side, I have 2 oxygen now. Now I have 2 sodium, I have 2 oxygen, and I have 2 hydrogen. And now everything matches. 2 sodium, 2 sodium. 2 oxygen, 1, 2 oxygens. 2 hydrogen, 2 hydrogen. So everything is balanced at this point just by putting this 2 coefficient out in front. And my coefficients for this equation are 2, 1, 1. I have a coefficient of 2, and these over here just have 1s because there is nothing in front. Okay, let's look at the next one. Fe plus O2 gives us Fe2O3. Okay, let's see what we got. We got 1 iron and, whoops, and 2 oxygen. Over here, we got 2 iron and 3 oxygen. We're not even close to being balanced. So we got to make all these numbers match on both sides. I'm going to start with the oxygen because we've got a 2 and a 3. And it's kind of like thinking of like a common denominator. If you had a 2 and a 3 in a denominator and you were looking for the lowest common denominator, you would pick 6. The lowest number that 2 and 3 go into are 6. So I'm going to just switch them, and I'm going to put a 3 here and a 2 here. That gives me 6 oxygen because 3 times 2 is 6. And over here, that gives me 2 times 3, 6 oxygen. So now my oxygens are balanced. but putting the 2 right here gave me 2 times 2. It now gives me 4 iron. So I need to have 4 of them over here on this side. And since it's all by itself, I can just put a 4 out in front. And now everything is balanced. And my coefficients are 4, 3, and 2. Nothing goes into all of those 4, 3, and 2. So those are all the lowest. So this equation is balanced. All right, let's try one more, or maybe more than one more. AlNO3 3 plus H2SO4 yields Al2SO4 3 plus HNO3. Whew, this one has a lot. So let's see what we've got. On this side, to start with, we've got 1 aluminum. And we've got this 3 has to distribute to both the nitrogen and the oxygen. So that gives us 3 nitrogen and 3 times 3, 9 oxygen. So that's what we've got right there. And right here we have 2 hydrogen, 1 sulfur, and 4 oxygen. So on this side of the equation, we now have 9, 10, 11, 12. We have 13 oxygen altogether. On this side, we've got 2 aluminum, 3 sulfur, 12 oxygen from right here, 4 times 3. And we've got 1 hydrogen, 2 nitrogen, and 3 oxygen. So we've got 15 oxygens. So now we got to try to figure out how in the world we're going to balance this. Nothing is balanced. We got 1 aluminum, 2 aluminums, 2 hydrogen, 1 hydrogen. The sulfurs aren't the same, the nitrogens aren't the same, and the oxygens aren't the same. So we got to figure it out. I'm going to start, and sometimes we start doing things and we have to erase it and change it. I'm going to start with the aluminum. We've got 2 on this side, so I'm going to put a 2 out in front of this. Now I've got 2 aluminum, and that 2 gives me 2 more of everything else in this whole compound. So I already had 3 nitrogen, so now I have 6 nitrogen. I already had 9 oxygen here, so now I have 18 oxygens. Okay, so we've got that taken care of. We've got the aluminum taken care of. Now let's see, those are the same. But now we have 6 nitrogens, and over here we only have 2 nitrogens. So how are we going to get, actually we don't have 2 nitrogens, we only have 1 nitrogen. I wrote that wrong, I'm sorry. That was 1 nitrogen, I don't know why I wrote 2 in the very beginning. We have 1 hydrogen, 1 nitrogen right there. So we got 6 of them over here. We have 1 here, so let's put a 6 in front of that nitrogen right there, or in front of that whole compound. Now that gives us 6 hydrogen, 6 nitrogen, and 6 times 3, 18 oxygen. Okay, so now our aluminums are balanced, our nitrogens are balanced, and that's about all. So let's see what else we can do. Now we have, oops, I'm sorry about that. Now we have 30 oxygen on this side. And on this side, we have 18, 19, 20, 21, 22. We have 22 oxygen. So we need let's see. If I put, and well, let's look at our hydrogens. We've got 2 hydrogens here and we've got 6 over here, so we got to put a 3 here. That gives us 12. And once we do that, that gives us 30 oxygen, which, whoops, that gives us 30 oxygen. So our oxygens are good, our aluminums are good, our sulfurs are now good, our hydrogens are good, everything's good, everything's balanced, and our coefficients are 2, 3, 1, 6. And there isn't anything that goes into all of those. I know that was really confusing, but you just have to figure out a way in your head how you're going to do things like that. You can write things like this, or you can just do it in your head and say, oh, I got 2 aluminums, I need to put 2 here, but putting a 2 there gives me this many nitrogens, so that means I got to change something here, and you can just go back and forth. And in the end, when you write your coefficients, if you happen to have gone too far and you've ended up with something like 4, 6, 2, 12, then you would say, oh, my coefficients 2 goes into all of those, so I need to divide them all by 2, and really my coefficients are that. That's why we write the coefficients, in case something like that happens. All right. So let's try some more on your notes. Al2O3 plus H2O yields AlOH3. Remember that this 3 has to distribute, this 3 right here has to distribute to the oxygen and the hydrogen. So this is how I start. Got 2 aluminum over here and only 1 over here, so I'm going to put a 2. Now my aluminums match. So I got, on this side, I've got 2 hydrogen, and now on this side, I have 3 hydrogen times 2, I have 6 hydrogen. So in order for there to be 6 on this side, I have to put a 3, because 3 times 2 is 6. So now I have my aluminums are balanced and my hydrogens are balanced. Let's check our oxygen. We've got 3 plus 3. We've got 6 oxygen on this side, and over on this side, we have 3 times 2. We have 6 oxygen. Everything's balanced, and our coefficients are 1, 3, 2. So that one is balanced. Okay, let's look at the next one. Pb NO3 2 plus AlCl3 yields PbCl2 plus AlNO3 3. Okay, let me get rid of that. Let's see what we need to do. I'm going to just start at the beginning. Lead and lead, they're already balanced, so I'm not going to worry about that right now, and I'm going to move on to something else. Aluminum and aluminum, already balanced. Now, if you look on your notes, it says, hint, if polyatomic ions stay together on both sides of the equation, they can be balanced as one item. This is what they mean. NO3, NO3. They're all together on both sides of the equation. Up here in this one, that didn't happen. Like here's an OH, but over here on this side, we never had an OH. So we had to think of them all separately. We don't have to, over here in this equation that we're working on, we can just think of NO3 as one thing. there are 2 of them here, 3 of them here. So that's like that common denominator thing. So I'm going to put a 3 in front of here and a 2 in front of here. Now I have 6 NO3s on this side, 3 times 2. And I have 2 times 3, 6 NO3s on this side. So those are balanced. Let's see what else I've got. I've got 3 leads. Over here, I only have 1, so I better put a 3 in front of it. Now I have 3 leads and 3 lead. How many, over here, putting a 2 in front of this one gave me 2 aluminums. I only have 1 aluminum over here, so I better put a 2. Now I have 2 aluminums. And I have 2 times 3, 6 chlorines. And over here, I have 3 times 2, 6 chlorines. So everything is balanced. And my coefficients are 3, 2, 3, 2. And it's all nicely balanced. Okay. Let's go on to look at some of the homework problems. Let's start with number 1. Okay, ClO3 yields KCl plus O2. Okay, they've given you that. All you have to do is balance it. 1K, 1K. That's already balanced. 1Cl, 1Cl. That's balanced. Uh-oh, we got 3 oxygen and 2 oxygen. So what are we going to do? When we have a 3 and a 2, we've got to put a 2 in front of this one and a 3 in front of that one. That gave us 3 times 2, 6 oxygen. It gave us 2 times 3, 6 oxygen. So now our oxygens are good, but this changed it to 2 potassium and 2 chlorine. We need to, over here on this side, we need to change these to 2, so we'll put a 2 in front of that. And everything is balanced, and our coefficients are 2, 2, 3. Okay? So good number 2. FeCl3 plus NaOH yields FeOH3 plus NaCl. All right, let's go ahead and balance this. We've got 1 iron, 1 iron. We've got 3 chlorine. Oh, only 1 chlorine over here. So let's put a 3 in front of that. That gave me 3 chlorine. That gave me 3 sodium. We only have 1 sodium over here. So let's put a 3 in front of that to give me 3 sodium. So far, our iron is good, our chlorine is good, and our sodium is good. We gotta look at this OH, and they're together. They stay together on both sides of the equation, so we can think of them as one thing. 3 times 1 over here, it gives us 3 OHs, and this 3 down here gives us 3 OH. So everything is balanced, and our coefficients are 1, 3, 1, 3. All right. Hopefully this is making more sense to you. And let's look at another one. We'll do number 3. Okay, these are on the homework. Al2SO4 3 plus CaOH2 yields AlOH3 plus CaSO4. 4. So first, let's look at the things that stay together. SO4, SO4. So we can think of them as 1. OH, OH. We can think of those as 1. So we've got 2 aluminum, 1 aluminum. So let's put a 2 there. Now we have 2 aluminums. That gave us 2 times 3, 6 OHs. Over here, we only have 2 OHs. So in order to have 6, we have to put a 3 in front. Now we have 6. Over here, that putting a 3 there, right here, gave us 3 calcium. Over here, we only have 1 calcium, so we better put a 3 in front of it so that there are now 3. So those are balanced. That gave us 3 SO4, and we already have 3 SO4. So everything is balanced, and our coefficients are 1, 3, 2, 3. Right? That is the kind of thing that you have to do for these problems. Let's do one. I'll do one more farther down, and then I want you to try to work on more of these. Let's do, which one should we do? Number 11. Okay, we got Bi2SO4 3 plus NH4OH yields B, whoops, what did it do? BiOH3 plus NH4 2SO4. All right, let's see what stays together. SO4, SO4, so we can think of those as 1. NH4, NH4, we can think of those as 1. OH and OH, so we can think of those as 1. So we have 2 Bi. Here we only have 1, so let's put a 2 in front. That gave us 2 of those. Doing that gave us 2 times 3, which is 6 OHs. Over here on this side, we only have 1 OH, so we better put a 6 in front of it. That gave us 6 OHs. And putting that 6 there gave us 6 NH4s. Over here on this side, we only have 2 NH4s. So in order to get 6 of them, we better put a 3 in front of it. 3 times 2 gives us 6 NH4. But putting that 3 there gave us putting that 3 there gave us 3 SO4s. Over here on this side, we already had 3 SO4s, so that's good. And let's just go through and make sure we got it all. 2 Bi, 2 Bi. 3 SO4, 3 SO4, 6 NH4, 6 NH4, 6 OH, 6 OH. Everything is balanced, and our coefficients are 1, 6, 2, 3 for number 11. Okay, that's how you do balancing equations. So go ahead and try and finish these, and you need to have a good grasp of this before you move on to lesson 4.